Okay, this is section 8.2 called Dividing Monomials, and this is probably the hardest section in this chapter. There are going to be 4 different parts to it that we're going to learn in this video. You may have to refer back to certain parts again. You may have to look at it more than once. We're going to be doing it for 2 days in class, 2 different homework assignments, and you have to know it well, but it might take you a while. Okay, so the first part about dividing monomials, the first thing that we're going to learn, I'm going to teach by showing this example. If I had 4 to the 5th power over 4 to the 3rd power, and if we were going to do this the long way, then that would mean I would have 4 times 4 times 4 times 4 times 4 on top, and just 3 of them on the bottom, 4 times 4 times 4. And every time you have 1 on top and 1 on the bottom, then you can cancel those and it would equal 1. So we'll cancel another set, it equals 1, third set, and it equals 1. And I've ended up with 4 times 4 on the top and nothing on the bottom except 1. So that equals 4 squared, which is 16. But the shortcut is that when you have division, you're going to subtract the exponents. So 4 to the 5th over 4 to the 3rd is going to equal 4 squared. So that's the rule no matter what, as long as the bases are the same. So if my bases are both b to the 15th over b to the 7th is going to give me b to the 8th. So when we have division and the bases are the same, we are going to subtract the exponents. Okay, so let me show you some more difficult examples. So if I have a to the 5th times b to the 8th over a times b to the 3rd. So I'm looking for the bases that are the same. And of course, if it just says a, that means it's a to the 1st. So this is going to give me a to the 5 minus 1, which is a to the 4th, and b to the 8 minus 3, which is b to the 5th. So in this particular one, there's nothing left on the bottom of that fraction, so that's the whole answer. Let's see, I think I have a harder one of those. Almost the same. Let's do x to the 8th, y to the 12th, over x squared, y to the 7th. So that's going to equal x to the 6th, y to the 5th. Okay, all good with that. Nothing too difficult yet. Okay, so the second rule is about powers of a quotient. And all that means is if you have more than one thing inside parentheses, and this is being raised to a certain power, then everything inside the parentheses goes to that power. So here I would have 2 to the 3rd power over 5 to the 3 power. And if you're going to work that out, that would be 8, 2 times 2 times 2, over 125. 8 over 125. Okay. So if you have variables inside the parentheses, then the same thing is going to be true. So c over d to the 5th is going to give me c to the 5th power over d to the 5th power. And with this one, there's nothing more I can do with it. That one has been simplified as much as it can. I'm going to give you two more examples of that. So if I have 2p squared over 3, and all of that is inside parentheses, and all of it's being put to the fourth power. Then I now have 2 to the fourth power equals 2 to the fourth power. P is going a power to a power, p squared to the fourth power, so I have to multiply those. That's p to the eighth over 3 to the fourth power. We're going to carry out these 2 to the fourth power, which means 2 times 2 times 2 times 2, which is 16, p to the eighth, and 3 times 3 times 3 times 3 is 81. Remember the good way to do that. Multiply the first 2, you get 9. Multiply the second 2, you get 9. So that's 81. Now, when I get to this answer, this one happens to be done. But if I could simplify this 16 over 81, then I would have to do that. So let me give you a problem where you have to simplify. So let's do 2a squared over 6c to the second power. And all of that is going to go to the second power. So that's going to give me 2 squared times a to the fourth power over 6 squared times c to the fourth power. So just remember that everything inside the parentheses separately, treat everything separately, and it all goes to the second power. So this now gives me 4a to the fourth over 36 c to the fourth. Now, this 4 over 36 is a fraction, 4 over 36, that can be simplified. So I have to simplify 4 over 36. 4 divides by itself once, 36 divided by 4 9 times. So because that changes to 1 over 9, we're going to simplify this as 1a to the fourth over 9c to the fourth, but I don't really want that 1 there because it's just a placeholder. So a to the fourth over 9c to the fourth. Now I would need that 1 there if that was the only thing left on the top of that fraction. If it was the only thing left in the numerator, it would need to stay. But because I have other things there, I can write a to the fourth over 9c to the fourth. Okay, so that was power of a quotient. The third thing that you have to learn is about zero exponents. And you did learn this last year, so you might remember, but I'm going to show you the long way. If I have 2 to the fourth over 2 to the fourth, that would equal 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2. When you have the same thing on the top and the bottom, they cancel out, equaling 1. So this whole thing cancels out to 1 over 1, which is just 1. All right, if I did this now with our shortcut of when I have the bases are the same, and I'm having a division problem, a quotient, then I can subtract the exponents. So that means 4 minus 4 is 0. So that means 2 to the 0 power equals 1. And it happens to be true that anything to the 0 power equals 1. This is something that you have to memorize. You can go back to thinking of it this way, the long way, to help you memorize it, but it's something that you just have to know. So therefore, every time I give you something to the 0 power, I'm going to write 3x squared y to the fourth over negative 39x to the fifth y squared, that whole thing to the 0 power. This is a problem that you're not going to do any work for, because you'll know that if everything in there is to the 0 power, then the answer is 1. More likely, you'll see something like, let's say 5 times x to the 0 power times y squared. Well, now only this part is being put to the 0 power, and that equals 1. So that's 5 times 1 times y squared, which would be 5y squared. Okay. Now the last thing that we're going to learn is the hardest part. The fourth thing in this section is negative exponents. And again, you were exposed to this last year, so maybe you'll remember some of it. So I'm going to do it the long way. First, if I had 8 squared over 8 to the 5th, well, this would give me 8 times 8 on the top, and this would give me 5 of them on the bottom. Now, whenever I have 1 on the top and 1 on the bottom, they cancel out, leaving 1. So now I have 1 on the top, like not 0 on the top, but 1, and I'd have to leave that 1. And I have 3 of them on the bottom, or 8 to the 3rd power. So what's happening here is if I'm subtracting the exponents, I would get 8 to the 2 minus 5, which is 8 to the negative 3. Well, the other way to write 8 to the negative 3 is 1 over 8 to the 3rd. This is a rule that, again, you were taught last year, but you have to memorize, that any number to a negative exponent equals that same number moved to the other side of the fraction bar to a positive exponent. N to the negative 2 equals 1 over n squared. 5 to the negative 2 equals 1 over 5 squared, which equals 1 over 25. Likewise, if you see the negative exponent in the denominator, then to make it positive, you would have to move it to the top, and now it's a positive exponent. So that'd be m to the 3 over 1, which is just m to the 3rd power. So you will never leave a negative exponent. So no negative exponents as answers. And instead of leaving a negative exponent, you're going to move it to the other side to make it positive. So let's see. Let's do some examples of this. I'm going to start with this. B to the negative 3, c squared over d to the negative 5. So all I'm going to do in this problem is move the negative exponents to the other side. C squared stays where it is. It's a positive exponent. You treat everything separately. B to the 3rd has to come down to the bottom to make it positive, and d to the negative 5th has to go up to make it positive. And then that's all you could do with that problem. Okay, next problem. Negative 3, a to the negative 4, b to the positive 7, over 21, a squared, b to the 7th, c to the negative 5. So first of all, this first part, negative 3 over 21, those are not exponents, they're regular numbers, and I'm going to simplify them. So that becomes negative 1 over 7, because I'm dividing them both by 3. Now, I'm going to leave that negative 1 up there right now. I don't know if I'm going to need it or not, but I'm going to leave it. Now, I'm going to take my negative exponents and move them to the other side. So I only have to deal with positive exponents. So a squared is on the bottom, and I'm going to leave it there. A to the negative 4, I'm going to bring it down. So I now have a to the 4th. I'm going to leave that for now. Now I'm going to deal with b to the 7th over b to the 7th. Well, that's the exact same thing. That's going to equal 1 on the top and 1 on the bottom. C to the negative 5th, I'm going to bring it to the top and make it c to the positive 5. However, I'm not done yet, because in your answer you can't leave the base written out twice. You always have to, when it's the same base, you always have to combine them. So right now I have negative c to the 5th, and on the bottom, bases are the same, I have to add the exponents. So 7a to the 6th power. And that's my final answer. That negative could be on the top, or it could be over to the side, or it could be on the bottom, as long as there's just one negative in the answer somewhere. The fraction is negative. Okay, now I'm going to do number 5. No, I already did that one. Number 6, and this is on page 421. Okay, so this problem is 2c to the 3rd d over 7z squared, that whole thing to the 3rd power. So all I'm doing in this problem is putting everything to the 3rd power. I'm starting by putting 2 to the 3rd, c to the 3rd to the other power of 3 means I have to multiply those exponents and get c to the 9th, d to the 3rd over 7 to the 3rd, and z to the 6th power. Okay, 2 to the 3rd is 8, c to the 9th, d to the 3rd, 7 to the 3rd is 7 times 7 times 7, which is 49 times 7, which is 343. Don't make a mistake doing that. Write it out. Z to the 6th. Okay, I have no negative exponents. I don't have any of my variables being repeated. I don't have more than one c, more than one d. I try to see if I can simplify this, if they have a common factor, but they don't, so then that's my final answer. Okay, now I'm going to do number 10 on that same page, page 421. Negative 5 p q to the 7th over 10 p to the 6th q to the 3rd. So I'm going to simplify the fraction part first. That gives me negative 1 over 2. Now I'm going to deal with the p's. I have p to the 1st over p to the 6th, so I have to subtract 1 minus 6 and get p to the negative 5. When you subtract, it always goes to the top. If you're subtracting exponents, it will always go to the numerator, the top of the fraction. Q to the 7th over Q to the 3 is Q to the 4th. Now to finish my problem, all I have to do is get rid of that negative exponent. So I'm going to write negative Q to the 4th on top, and this has got to come down to the bottom. So I have a 2 on the bottom, and now P to the 5th. And that's the final answer for that one. Okay, now I'm going to do number 11 on this page. CD to the negative 2, all of that's going to the 3rd power, over C to the 4th, D to the 9th, all of that is going to the negative 2. So my first step is to put these things to their exponent. I have C to the positive 3, D to the negative 6, over C to the negative 8, D to the negative 18. Now I'm going to make the negative exponents be positive. I'm leaving c to the third where it is. C to the -8 on the bottom, I'm going to bring it up and have it c to the +8. D to the 6 I'm going to bring down, so it's d to the +6. D to the -18, which is on the bottom, is going to the top, d to the +18. Now I'm just going to combine when I have the bases that are the same. That's c to the 11th, and with the d's I have to subtract. 18 minus 6 is 12, so that gives me d to the 12th. There's nothing left on the bottom but a 1, so I won't need it. So I have c to the 11th, d to the 12th as the answer.